Welcome to Math with Professor V. This is video lecture for section 4.4 for business calculus on derivatives of exponential functions. So we're going to learn one of the most beautiful derivatives there is out there, the derivative of e to the x. And lo and behold, it's just e to the x. So you take the derivative of e to the x with respect to x, you get back e to the x. There's a funny meme about this derivative. I posted it on my Instagram if you're curious, so go check it out. I didn't create it, but it's funny. Also, what if the base is not e? What if we have some other constant a? So for any positive constant, as long as a is not equal to 1, then the derivative with respect to x of a to the x is natural log of a times a to the x. So basically, if the base is not e, you just slap on an extra natural log of whatever the base is. And actually, that's the more general rule. When you take the derivative with respect to x of e to the x, you are using that rule because you have natural log of e times e to the x. But we know natural log of e is just 1. So that's why you don't see it. You don't see it pop up. But if you were trying to take the derivative of some exponential function with a different base, say 5 to the x, then it's 5 to the x times natural log of 5. Or you could put the natural log of 5 in front. Doesn't really matter. Okay, very good. Let's practice some examples now so that we can get the hang of this differentiation rule. So find the derivatives of the following functions. First one is f of x equals 3 times e to the x. No, we're not going to use the product rule because remember, 3 is just a constant. It's not a variable function. So it's just going to come along for the ride when we take our derivative. F prime of x equals, just leave that 3 alone. And then now we're going to multiply by the derivative of e to the x, which we just learned is e to the x. And that's it. We're done. Yes, indeed. Okay, carrying on. G of t equals pi raised to the t. So the base is pi. That's a constant. T is the exponent. So I'm finding g prime of t. And keep in mind, you take the derivative. Pi to the t is going to be pi to the t times natural log of the base, which is pi this time. Good. We okay? All right, next one, let's be careful. H of x equals negative 8 to the x. Now remember, when we looked at the differentiation rule up above, I said the derivative of a to the x applied for any positive constant. So that means the base here can't be negative. And keep in mind your rules of exponents and parentheses. Negative 8 to the x is not the same as the quantity negative 8 all raised to the x. In this case, the negative is included in the base. It is not included here. So if there's no parentheses grouping the negative with the 8, you don't assume that it's part of the base. You just assume it's a negative hanging out by itself, okay? Watch out. This is something to be careful about. These are the watch out eyeballs. Okay, so now let's proceed. Let's take the derivative. H prime of x. That negative just comes along for the ride. It doesn't do anything. It's just hanging out. And then derivative of 8 to the x would be 8 to the x times natural log of 8. And then that's it. I would just box it and move on with my life. Good? Okay, now that we've hopefully gotten the hang of just the basic derivatives of exponential functions, let's build on this and see how it works with the chain rule and product rule and quotient rules. So find the derivatives of the following functions. Y equals 1.2 times e raised to the 5x. Again, let's find dy dx. The 1.2 is just a constant. It's just going to come along for the ride. Then we have derivative of e to the 5x. So think of it this way. Derivative of e to the something is itself e to the something. And then because of the chain rule, I have to multiply by the derivative of the something, of the exponent. And the derivative of 5x with respect to x is 5. Very good. So we've got 1.2 times e to the 5x times another 5. Let's combine those constants. 1.2 times 5 is going to be 6e to the 5x. How was that? You guys okay? All right, let's try another one, a little bit spicier. Y equals negative 5 times e to the 4x cubed. Why don't you pause the video, try it on your own. Did you try it? I hope you did. Okay, dy dx, or you could write y prime. Nothing happens to the negative 5, just comes along for the ride. Derivative of e to the something is e to the something. Then I have to multiply by the derivative of the something because it wasn't plain old x. Derivative of 4x cubed, 12x squared. Excellent. Then just call in the cleanup crew. Okay, so negative 5 and 12, we can multiply those and then put the x squared in the front. It's going to look so much better. So we'll write our final answer as negative 60x squared e to the 4x cubed. Et voila, there you go. How was that one? Did you get it right? Okay, good. Next one, example C. Y equals x squared times e to the negative 2x. Ooh, okay. So this time we do have to use the product rule because notice we have a product of two functions of x. So here we go. Dy dx, or y prime. Derivative of x squared is 2x. Then leave the other function alone. Plus, now I leave x squared alone. Now I need the derivative of e to the negative 2x. So derivative of e to the something is e to the something. Then by the chain rule, I have to multiply by the derivative of the something, of the exponent. So what's the derivative of negative 2x? Yes, negative 2. Excellent. How are you doing up to here? We're good? Okay, so now let's see how we're going to clean up and simplify. This is 2x e to the negative 2x. And then let me group these two terms in the front. So minus 2x squared e to the negative 2x. And in just a few lessons, you're going to see that when we take derivatives, we're going to do something with them. We're going to set them equal to 0. This is a little sneak preview. So in order to solve more easily, it's helpful if you factor your derivative as much as possible. On that note, what can I take out of both of the terms here? I could take out a 2x and an e to the negative 2x. So let's do it. 2x e to the negative 2x. And then I'm just going to be left with 1 minus x. Okay, so technically in the lineup above, things were cleaned up, but this is a better way to write your final answer because it's going to be useful and necessary in the coming lessons, okay? We're not just taking derivatives for fun because we think it's like a cool thing to do. There's a purpose to it. Okay. Next one, y equals e to the x over 2x plus 1. So in this case, we need to use, very good, the quotient rule. So here we go. I'm going to sing the little song. Not really sing, I will recite it for you. I'll spare you all the horror of hearing me sing. So we have low d high. Low is the denominator. D high means derivative of the numerator. Derivative of e to the x is e to the x. Minus high, that's the numerator. D low is derivative of the denominator, that's just 2. Over low low, denominator squared. How'd you do? Good? Okay, now look at the numerator. There's two terms. What do they have in common? What can I factor out from both? Just e to the x. Just e to the x. You can't take a 2 out because this is not matchy-matchy. It's not a 2. It has to be exactly the same if you're going to factor it out. So I can take out e to the x, and then I'm left with 2x plus 1 minus 2 over 2x plus 1 quantity squared. And then we can clean up inside those parentheses in the numerator, e to the x times 2x minus 1 over 2x plus 1 squared. And we are done. Good? Okay. Couple more. Y equals negative 4 raised to the negative 3x plus 1. So what I think is good, anytime you see that minus sign, just remind yourself it's a negative 1 times the exponential function. So you don't get jumbled up thinking it's part of the base, okay? Good. So dy dx equals, that negative just comes along for the ride. Derivative of 4 to the something is going to be 4 to the something times ln of 4 times the derivative of the something. So the derivative of negative 3x plus 1 with respect to x is, very good, negative 3. Okay, now we can still clean up because notice I have negative 3 times negative 1. That's going to be positive 3. And then you can either put that in front or behind the base. Let's just leave it all at the back. So 4 to the negative 3x plus 1 times positive 3 ln of 4 now. That's one way you can write your answer. It's also fine if you were to put 3 ln of 4 first and then 4 to the negative 3x plus 1, but I think it's a little dangerous. I think students might be tempted to combine these even though you definitely shouldn't. That's illegal. We're not allowed to do anything like that, but I just feel like this is a little more tempting to do illegal things. So I would advise against, let's just leave it like this, okay? Feels safer. All right, I got one more like this, and it's a spicy one because notice we have to not only do the quotient rule. When we take the derivative of the numerator, we need to also use, that's right, the product rule. See, we have a product of two functions, t squared and e to the 2t. So here we go. Let's just do this very carefully. dy dt is going to be, let me just make a big line for the quotient. Okay, low, so that's the denominator. That's low. D high means derivative of the numerator. So I'm going to do the product rule now to take the derivative of t squared times e to the 2t. So first let's do derivative of t squared, that's 2t, leave e to the 2t alone, plus for product rule. Now I leave t squared alone, he already had his turn. Now I need derivative of e to the 2t, that's e to the 2t, and then don't forget the chain rule, derivative of the exponent is 2. Okay, so this is low, this is d high. Minus, now I need high, so that's the numerator, don't touch it. This is high. D low, derivative of the denominator. So derivative of t plus e to the 3t, that's going to be 1. Plus derivative of e to the 3t is e to the 3t times 3 because of the chain rule. So here's my d low. Good? And then the last part's always the easiest, just low, t plus e to the 3t squared. Okay, now let's clean up very carefully, okay? I'm looking through, everybody has e to the 2t. I can factor that out. And that's pretty much it that's popping out at me. So let's do that, e to the 2t. Then I'm going to be left with t plus e to the 3t times 2t plus 2t squared minus t squared times 1 plus, let me write this as 3e to the 3t. How are we doing? Okay, so remember there's only really two terms in the numerator. There's only two terms. You have this one minus this one. When I take out e to the 2t, that removes both of these because this is one factor here. Boom. And then I take it out from here. There it is. Okay, good. Now it's probably time to expand inside the parentheses that are in the numerator. So let's start multiplying things out. So I have e to the 2t times. This is going to be 2t squared plus 2t cubed plus 2t e to the 3t plus 2t squared e to the 3t, yes? and then minus t squared minus 3t squared e to the 3t. I think that's everything. Over t plus e to the 3t squared. Let's double check. Yep, everything's good. Okay, so can we combine some like terms? Leave this e to the 2t outside. 2t cubed is the only t cubed there is, right? Poor thing. Okay, so 2t cubed. T squared, there's only the one, 2t squared. Oh no, I lie. There's minus t squared over there. Okay, perfect. So 2t squared minus t squared gives me 1t squared. Perfect. I was feeling bad for it. Let's see what else. Then we have here 2t squared e to the 3t, negative 3t squared e to the 3t. So that's negative 1t squared e to the 3t. And then we're just left with 2t e to the 3t all by itself. All over t plus e to the 3t squared. Good? Let's box it with pride. That was well done. Okay. Last one, we're going to ask a question that we've solved many times already in this course, but now we're going to apply our new differentiation rules. Find the equation of the tangent line to the graph of the function at the given point. So the function is e to the x over x squared, and the point is 3 e cubed over 9. So I know to get the equation of the tangent line, I need m tan, slope of the tangent line, which I get from first taking the derivative and then plugging in the x value that's given to me. So in this case, it's going to be f prime of x, but f prime of 3 at x equals 3. And then I'm just going to use the point 3 comma e cubed over 9. That's my x1, y1, and I'll put it all together in point slope form. So first things first, I need my derivative. I need f prime of x. And yes, it's time to do the quotient rule again. Except this time it's more straightforward because we just have one term in the numerator, one term in the denominator. So we don't have like double quotient rule, product rule situation. Okay, here we go. So we have low d high, which is e to the x, minus high, d low, derivative of x squared is 2x, over low, x squared squared is x to the 4th, yes? Good. Now factor out the GCF from the numerator. So what do both of these have in common? I can take out an x and an e to the x. So let's do it. Then I'm left with x minus 2. And this is all over x to the 4th still. Do you notice anything we can do? We can cancel this x, and then now this is just x cubed. So I can write f prime of x, completely simplified, is e to the x times x minus 2 over x cubed. Okay. So now let's get the slope of our tangent line. M tan is f prime at 3. 3 because that was the point that they gave me, yes? Okay, good. Now don't be scared, it's gonna look a little funky. It's gonna be e cubed times 3 minus 2 over 3 cubed. So that's e cubed times 1 over 27. So that's our m, okay? Yes. Look at things getting interesting. However, it is refusing to be boxed. Look at that. I mean, maybe it's too early. I've been up since 4. Okay. And then the point that we're using is 3 comma e cubed over 9. That's my x1 and y1. So here we go, straight to point slope form. Y minus y1 e cubed over 9 equals m times x minus x1. All right, just carry on. No panic attacks. You've got this. Y minus e cubed over 9 equals, distribute, e cubed over 27x minus, now this 3 is going to cancel with the 27, and I'm going to have e cubed over 9 over here. And then I want to move this over. So let me add e cubed over 9, add e cubed over 9 so I can get y all by itself. And then lo and behold, this is gone. This constant cancels out too. And I'm just left with y equals e cubed over 27x. Wow, so beautiful. Oh, now it's cooperating. Look at that. Okay, so that concludes the video. Hope it was helpful and that you enjoyed it. Just keep practicing. Derivative of e to the x is e to the x. I love it. Don't you love it? Usually students don't like e when they're learning exponential functions until they get to calculus, and then e to the x becomes their favorite function. So I hope you feel the same way. Give the video a thumbs up. Don't forget to subscribe and stay tuned. There's going to be more business calculus video lectures coming soon. Also, if you want to see that funny meme about e to the x, then just head over to my Instagram, Math with Professor V. I'm also on TikTok quite a bit. Same handle, and Twitter. Thank you guys so much for your support. I'll be back sooner than later. Bye.